Do a little bit more on divergence theorem today, and then we're going to take a peek at Stokes.
Are you stoked, guys?
I have a pro. Yeah, calculus. You know, I all semesters say that.
No, that's right. I just thought about it, guys. But I will be waiting all next semester to say that, guys.
That's the roll over there. That's not me though. I don't know what's going on with this. The L on the bottom canceled. You're an L. L. Plug in the game and get rid of it.
So we got z squared is a squared minus x squared minus y squared. So x squared plus y squared plus z squared equals a squared. We have a sphere of radius a, and it's only the upper half.
Here's too many flat tries. Cold.
It's a Benjamin. And he is late.
Kyle Benjamin.
Give you another couple minutes, 2 minutes.
So like. Don't you like it? Shouldn't that be enough? No, I thought I'm more tired. I just like. It is cold. That makes me tired. The cold makes me tired. It doesn't make me up.
It's definitely, it's better than being like comfortably warm, because that'll make you even more tired.
Yeah.
Or like the lights really dim, that really makes you tired.
It's different. You're like, you get the dark too. You're like, no. That's why that's I miss that. Why I miss like the last of was why I miss like this last night didn't go. I laid in my bed waiting for like 7. Then we could 6 again, and I was just waiting for time to pass. I had my cat, and I was like, I had my cat like next to me, and I just fall asleep. They didn't have a choice. Because I put them on my blanket and they would just stay there. If they couldn't see an escape, they would just lay there. And then when I took my blanket off, they did run away.
So I was, James, you'll like this. I was talking to a friend I went to COS with, and I was telling him that I was teaching Mr. Blakely's son. And his first response was, "But Mr. Blakely." Did your dad tell you that I saw you or him and your brother at Starbucks?
Oh,
Your brother's very social. He started telling me about Super Smash Brothers, asked me if I game or what games I play. I don't even know how he knows I'm a gamer. No one would suspect another professor to be a gamer. But he knew I was a gamer. He just came and started chatting with me, talking about video games.
I don't know how you don't suspect a Discord junkie to be a gamer as well.
Right. All right, let's take a look at it. We need to do the divergence of F to proceed. So for those of you that have not been doing your homework, divergence of F is ddx, ddy, ddt dotted with F.
No, dude.
F dot DR.
Yeah. Oh, you spirit.
It's a sphere, but I was like, I don't like the rho squared and sine theta. I mean,
So that's what's in our integral.
that makes
We got
sense.
5z dv. The question is, how do we want to tackle the dv?
Because that's
I think X, Y, and Z is the hardest route to go. We're better off with spherical or cylindrical. And of the two, I think spherical is the easiest, as long as you can remember the formulas.
I was just doing it the
A lot of you guys have been struggling on the test because you don't have the formulas for spherical and cylindrical memorized. Memorize them. So in spherical, Z is rho cosine phi. So we would have 5 rho cosine phi. Then what are our limits of integration? Well, rho is between 0 and alpha, not alpha A. Theta is doing the full circle. And we're only doing half the sphere, the upper half. So phi is going from 0 to pi over 2. So when we set up our integral, what do we get? We'll do theta on the outside. We will do phi next. We will do the radius next. I have 5z, which is 5 rho cosine phi. And then don't forget, when you do spherical, we need the correction factor, which is rho squared sine phi. D rho, d phi, d theta. Now, if we want to collect to get everything looking organized, we got 0 to 2 pi, 0 to pi over 2, 0 to a. I've got 5, I got rho cubed, and then cosine phi sine phi. D rho, d phi, d theta. So I do not have any variables in the limits of integration, and these are all products. There's no sum or anything, sum or difference. So this is separable. We can write this as 0 to 2 pi d theta, and maybe I'll put the 5 over there. Then we got 0 to pi over 2. Cosine phi sine phi. D phi. And finally, 0 to a rho cubed d rho.
Oh. We have wrong.
So it looks like we might want to do a sub on blue, my phi. So we could do u equals sine phi. Du equals cosine phi d phi. And then when phi equals 0, u equals 0. And when phi equals pi over 2, u equals 1. Which will change that interval from to 0 to 1 of u du. All right, so we start integrating 0 to 2 pi, 5 d theta. We integrate that, that's just 5 theta from 0 to 2 pi. Our u is just 1/2 u squared, evaluated from 0 to 1. And our rho is 1/4 rho to the 4th, evaluated from 0 to a. So we've got 10 pi. We've got 1/2. And we've got 1/4 a to the 4th. And gathering it all together, what do we got? The 10 and the 2 simplify to 5. We've got 5 over 4. I've got an a to the 4th power, and then I've got pi.
Oh man, I love that number. It's my favorite number.
Hey, good, bro.
5 over 4, 8 to the 4th, 5. Like I said, it's my favorite number.
I guess I'm gonna do it. Okay.
Oh, yeah. I'm a little bit screwed.
Any questions? You guys ready for more?
So would this problem be possible in rectangular?
Would this problem be what?
Possible in rectangular?
Oh, of course it is.
It would be painful, but yeah.
Rectangular is going to be hard because we've got 5z and z is that. And so I don't know what you're going to integrate to deal with the x and the y. You're going to have to remember the trig formulas and shit like that. So yes, it's possible. And if you're lazy enough to not want to memorize spherical or cylindrical, knock yourself out failing the problem trying to do that with XYZ. Please memorize spherical and cylindrical. They are not that hard. These are college students. And a lot of you do have memorized. You've got to memorize, but some of you don't. Some of you don't have polar memorized. Those are fucking 3 equations in polar. I mean, how hard was that?
R cosine theta, R sine theta.
All right. Let's take a look at Stokes. So Stokes' theorem is a generalized version of the Green's theorem, our circulation version. Those of you that are looking at Discord, Mike mentioned the other version of Green's theorem, which is just the 2-dimensional divergence theorem. And since we do it with divergence theorem, there's no need to separate it out. Stokes' theorem is the line integral. Oh, let's put a C in there and an S. The closed line, and dr is a vector. F dot dr, line integral of f dotted with dr is the same as the curl of f dotted with n, the surface integral for the surface bounded by the closed integral. Now, if we're given the line integral C in the curve, the surface, it may be given to us, but we can even pick it at some points if it matches well. I kind of like what we've got going on here, though. Let's verify Stokes by doing both sides of this. So let's do the left-hand side first.
How about we let it write down first?
It might help to look at the surface.
Lauren says he wants to write it down first.
I know. I've been talking for, if you need longer to write it down, write it down.
It's Pohl's theorem. It's Pohl's theorem.
Come on, Lauren. We're faster. Yeah, Lauren.
Professor Jones's theorem.
You should be able to predict what Mr. Jones is about to write.
Where's Jones's theorem?
Mr. Jones is about to write the picture or draw the picture of the surface.
Oh, that
goes way up to 9. I ain't gonna fucking draw the scale there, am I?
I want to make earlies.
But that's where x equals 3. Y equals 3 is there. It's coming down there. And we got this circle going in the XY plane.
That is really useful. That sounds cool.
So the surface part that we're actually looking at, let me do it in a different color, because we're not looking at a solid. We are looking at just this parabolic surface.
Stay away.
So the line integral, if we project this into the XY plane, the line, our curve is going to be this bottom part here. That's our C, where this is our S. So C is the circle of radius 3, right? So if with that in mind, we might want to parameterize R with a circle. That would be X component would be 3 cosine T. Y component is 3 sine T. And 0. So dr is negative 3 sine T, 3 cosine T, and 0. Now we want to dot that with F. So we're doing Z minus Y, Z plus X, negative X minus Y, dotted with that.
Perhaps, isn't it in DS? Isn't the go with in DS? It is like last time. Right.
We're doing the left side of the line integral first. We're doing the left side first. F dot dr. So we've
Yeah, I
got
got a
Z
question.
minus,
I know I
What?
asked this about the last one too, but are we not supposed to normalize n again?
no,
Sure.
Why not?
well, first off, we're not even working with N yet. If you go through, and I'm not going to rederive it, it takes a while. You can watch the video on how DS, when we use DS and the Jacob, we switch to the Jacobian, it cancels out with the normalizing part. That's back in when we were doing surface integrals before. That part hasn't changed. F dot dr though
keep thinking that the definition of the N is the derivative of R normalized, but I guess that changed.
Well, you can tell if it's normalized if it has if it has a hat. The hat means it's normalized and it's been normalized. Or it's like the unit vector, the unit N. Versus just the arrow, which is just like.
Okay, so that's my f.dr, and we don't want it as is. We need to get rid of the z, y, and x. So for that circle,
That's what I do.
z equals 0. Y is 3 sine t. And x is 3 cosine t.
X is gonna be negative 3 sine t. Or sorry, that's never mind. Scrap that. Or wait. No, because that's.
So when I plug it in, I've got negative 3 sine t times negative 3 sine t plus 3 cosine t times itself.
Oh, that's.
So f.dr is 9 sine squared t plus 9 cosine squared t, which is just 9.
That's crazy. They factor out the 9, get the sine squared, cosine squared equals, that's equal to 1.
I can't believe it.
So we are, the parameter we have here is t is the angle. So we're doing 0 to 2 pi of 9 d theta or dt.
I got lost after that. Oh, I see the world now.
Because we're doing, this is the closed integral of f.dr. The closed dr, when we parameterize the t, we're switching to the angle. So we're sweeping out the angle of the curve. F.dr was just calculating what is in here. So there's the 9 in there. When we evaluate it, I've got 9t from 0 to 2 pi or 18 pi.
Number.
It was just like the other field, was it called? I think it was called. Yeah, he uploads here.
If there's a name out there, there's a theorem for it.
Now we'll do the curl of f.n on another whiteboard. So I'm gonna write that part down and copy everything over that we need before I change boards.
Oh, yeah.
Really? What is it?
This is a guy named Arnold, his favorite.
I thought we were told or something, that's according to that.
Keep the kings
Never
there.
last year, disturbing, and non here.
So yeah, the that's
I guess it makes sense. It's like, of course,
oh, just the next place. Yeah, and then he thought it would. I don't understand any of these things. I'm gonna just do them out. Like. I didn't.
Oh,
I think. Oh, we're only names.
James, I found your theorem.
Blakely's theorem. What is Blakely's theorem? Drop.
you guys ready to do the right side?
Well, actually, I would just be like, theory of. He's gonna rediscover.
So we need to do the curl of f.
Blakely's theorem.
Folkman Lawrence topological representation there. Apologies, apparently.
Theory of everything. Yeah.
So this is my curl of F.
Oh, so wacky.
So for curl of F, for the I component, I have ddy of this is just -1 minus ddz of that is -1 again. And then I've got minus j hat. ddx of that one is -1. Minus ddz of that one will be minus another 1. And finally, we have our k hat. ddx is 1. Minus ddy is -1, so minus a -1. So what do I have? -2, +2, and +2 for my curl of F.
What?
But like the K had stuff before,
What?
like I
Like
had
the
and then
middle
printers, yeah.
Oh, well, you can do that. So we always. You can also just
So we
expand
write it
it
out.
here instead. Up to you.
I always read it out.
You can write in either way,
But yeah,
but you'll see both.
I know. But that's
What's the issue?
No, Lawrence is just commenting on your notation. That's all.
What's
Your,
wrong with it?
vector notation. There's nothing wrong with it.
Lawrence is looking for an F.
No.
All right.
No, it's 'cause when you put I had, J had, and K had, normally we write it, like after the parentheses.
Oh, that's what you mean.
Oh, yeah, I would, what I had initially intended to do was do it like this. And stack it vertically like that to show it left to right. Yeah. I did it here. The only reason I did it here, if I were to write this normally, I would write this. Now that I've got it done, I would write it as that. I would not put the IJK first. The only reason I did it here was so it's easier to track what's in the parentheses. I didn't want to write the parentheses and do an I afterwards and then fill it in. But yeah, you definitely want your unit vectors afterwards when you're done. So what is N?
It's like 3.
N, remember, we can do the gradient of G. And G is Z minus G of XY. This, when you speed it up, this ends up being -ZX, -ZY, and 1.
That's true. That's, but you're supposed to subtract it within.
Yeah.
Yeah, it's just -1 minus +1.
So here's my Z up here. If I do the derivative of that with respect to X, it's -2X. And then I've got another negative. I'm going to make sure I write them down both just so I don't lose anybody. Same thing with -2, -y squared. I got the negative from here, and then dz dy is -2y.
No, I know, I just would, for some reason I combined my 9 with my next squared.
Oh.
Negative 9x squared.
Why is the negative?
So my n is 2x, 2y, and 1.
That's the derivative that's, that's
Of the.
basically
negative x
partial
minus
of.
y, which is.
In terms of- Yeah, yeah. Yeah,
I was doing it this way. Or you trying to doing it, supposed to do it that way. Pretty sure it's gonna go like that.
That's so too, but that doesn't make sense for I, so it's like.
Oh, does it not?
Oh, shoot. First line, I misremembered how to do the cross product.
Oh, yeah, oh, it looks right.
And I was right.
So now let's dot them. We got curl of f. Remember doing curl of f dotted with n. So that's -2, 2, 2 dotted with 2x, 2y, and 1.
So look like this.
I've got -4x plus 4y plus 1 ds.
Plus 2.
Yeah, it's +2.
What?
Did you do the last one wrong?
You put on 1 instead of 2.
Okay, never mind. I just
Top
put it
or
wrong.
not? Yes, right.
What you grabbed?
All right, so our surface, we can use any surface we want that goes with that circle in the XY plane. I think the easiest surface to do is not the
Choice, good choice.
parabola. We've got the disc right here. Something's off. What am I doing wrong?
My life. The face, oh my goodness.
So we have. I'm going to switch to R and theta. Something's off. What am I doing wrong?
Oh, is that not -2x and -2y? That's negative
Oh.
z partial of x partial z terms of x.
Yeah. Like what?
The base.
That's an answer.
To get that.
We're doing X and Y. So in the XY plane,
That's the gradient of g.
we have Y is, I think we're better off going to R and theta, don't you?
Where like x is the x.
So 0 is less than R, less than 3, and theta is less than 2 pi.
Or no.
Oh.
It's getting hard. You guys are struggling too? Oh, I've been lost since chapter 1.
Move this over to the side a little bit.
At least I know.
So if we distribute that out, what do we got? We got, don't forget the R for the correction factor. We've got -4r squared cosine theta plus 4r squared sine theta plus 2r dr d theta. This is not separable because we got plus signs. So we should just integrate.
The lowercase g.
Oh, that is just, because z is the function of those things. So we just call it g.
So there's two places.
Yeah, I believe. That's what it is, it's the e to the whole of f. And then he dotted with the n. So it's gonna have like that.
So that's where I'm at right now.
I'll do that, by the way. Shorter.
So when I do this one, I got 27, I got 3 times 3 times 3. One of the 3's cancels out here. I've got -36 cosine theta plus 36 sine theta plus 9 d theta and 0 to 2 pi. And you might be going, holy shit, how are we going to get this down to 18 pi? Because we know this is 18 pi. We just did the left side.
You just take out.
Just remember, we've got cosine theta and sine theta, and our limits of integration are 0 and 2 pi. So this is going to go to 0. That goes to 0.
Other part of the integral evaluating. Is that?
And we just are left with
No, that's
9
gonna
theta.
turn out.
I don't mind the fucking R being evaluated.
Yeah.
And
Is there an issue?
No, it
I
was
forgot that R was being evaluated.
Oh, okay.
dot to 0 might come into play, but you forgot we were dealing with the R instead of the theta.
Like friction, like that looks like that's friction. I'll be like, I don't know. D with Z. I think it's not bad. It's really. I think I need to address. Like my.
And we obviously don't have time for another problem, so will be it for today. If you guys have any questions.
Yeah, I'm gonna go to the Mason Center and just sleep.
Yeah, so that's the first.
I'm like dying.
Can you go over where you got where you did the big G?
You said any 0, 1. Yeah.
I can't hear you. So someone was asking me to go over something.
Can you go over that G is equal to Z dot G of X and Y? Because I thought G was Z. So I'm confused about why you're dotting.
I mean, that's how we tackle those other problems where we had like flat surface.
Can you come closer to the thing and talk to or have Brandon tell me what you're saying? I hear Z.
Right here. Sorry, what's the question?
So where you did G is equal to Z dot B. Can you go over that? I'm just confused because G is.
That's Z minus.
That's Z minus.
Oh.
Wait, what? Oh, well, that way.
And we did this in previous sections. We did this in 15.6. It's the same thing as 15.6.
I was confused. I thought that was a dot. I was really confused because I thought
That makes sense why you're asking that question.
That's why it's not working.
It's a partial, it's not, they're not actually multiplying by each other. Yeah, yeah. It's just a.
How many emails do you have? Full of liquor, buddy.
Have a good day, guys.
All right, you too. See you tomorrow. That's not. Today's not linear. Today's not linear.